because everybody was partying. So thank you. I think most of you know my name is Hardy Fink, and for the last 10 years I've been in charge of the FIG education programs, including academies, the age group development competition program, and special projects like this. We call it a workshop, but workshop is kind of a wrong word because there are too many people for a workshop. It's a seminar. So we began this process of, I'll use workshops, 3 years ago. First time was in 2013 for rhythmics. And it was intended as professional development for coaches initially that had completed our level 3 academies and what can we do for them afterwards. But to have special events would be very costly for everyone and a little hard to organize. So we felt it's best to connect them to the World Championships. And we started first for rhythmic gymnastics, the topic of music and creativity and so on, for judges and coaches. And in the meantime, we've done the other disciplines. Men and trampoline were also supposed to be last year, but Dr. Heinen was not available last year. So I think you had a judging symposium last year, which everyone was happy to have input into the code of points. So that was a good replacement. So then the thing then to decide is what topic should we present at these special seminars at the World Championship, what would be of interest to all. And I did communicate with Steve Butcher to see what he would like as well. And we agreed on 2 topics. One, the lost skill syndrome, and probably every one of you has encountered a gymnast that has lost an element for some confusion, whatever. And the other one is visual control or gaze control of complex movements. And the next thing is to find an expert that knows about this stuff. And so I'm so very, very pleased to have found Dr. Thomas Heinen, who's hiding back there. And he's, at the moment, I have to make this correct, he's a professor of social sciences of sport at the University of Heidelheim, near Hanover. Before that, he worked as a researcher and a professor at the Sport University in Cologne in psychology, the Department of Psychology. He is a physiotherapist, a registered physiotherapist, registered sports psychologist. He's a consultant for multi-sports, but including trampoline and gymnasts. And he, even though he's tall, he was a gymnast at one time, but he wasn't at the Olympics. So with that introduction, it's my great pleasure to introduce Dr. Heinen, and I'll turn it over to you. Oh, just what we'll do is we'll go till about 10:20, 9 till 10:20, 40-minute break, 10:40 to 12. Okay? Enjoy. Thank you.
Thank you, Hardy. Thank you very much. So, dear Hardy, dear coaches and colleagues, many thanks for this kind invitation and the opportunity to give this lecture in front of this great auditorium, of course. So, after a short introduction, I want to talk about the idea of perception-action coupling in complex gymnastic skills. I will then try to focus on a particular aspect of visual strategies, namely eye movements in complex skills, and I will talk about how to measure them and maybe how to use this as an approach for new training ideas. The second part of my talk comprises ideas on the role of environmental information in the regulation of gymnastic skills. I will focus on vaulting performance, and in particular the role of the springboard in movement regulation, as well as the dynamics of the tasks should be emphasized. I will end up with a short summary and a conclusion. So let's start with a short introduction first. As I said, I want to focus on complex skills and gymnastics in my talk because they are the most interesting skills humans are capable to perform. And you see an example for a rather complex sequence here. I think we also saw it exactly like this in the competition yesterday. And in order to prepare the following slides, maybe you could focus on the head of the gymnast during this routine and during the twisting somersaults in particular. And maybe you could think about what his head is doing or even what his eyes are doing during this somersaults with twists. If you focus on the eye and the head, then the idea of visual spotting becomes obvious. So what you see here is that the gymnast seems to focus his gaze on the floor during the somersault. You see these arrows here, so it seems as if his head is not moving during this sequence, but rather he directs his gaze towards the floor, thereby counter-rotating his head with the rotation of the twist in the last part of the somersault. This technique is called visual spotting in gymnastics or visual anchoring. So gymnasts attempt to fixate their gaze on specific locations in order to enable the visual system to provide information needed in the performance of an aerial skill, so it's spatial information actually. A second interesting aspect is that even at high angular velocities, experts usually have their eyes open. You can see it in this picture, so he's doing a twist with a very high velocity. Sometimes this velocity outperforms the functional range of the vestibulo-ocular reflex, but for some reason gymnasts are able to keep their eyes open, so they adapt to training and also adapt their visual strategies. So having said that, I want to come to the idea of perception-action coupling, because this idea forms the theoretical background of my talk. The idea of perception-action coupling has a long and very strong tradition in ecological psychology. It goes back to the preliminary works of Gibson on optical flow, and what Gibson tried to understand was how jet pilots use optical information when to control an airplane at very high velocities. So maybe you could not compare running towards a vaulting table with directing an airplane through space, but the basic idea is that an actor or a gymnast moves in a particular environment and grabs up information from the environment, such as the picture of the vaulting table on his retina. This information is used to regulate action in order to achieve a particular movement goal, such as a precise interaction with the springboard. So you run towards the springboard, the retinal picture of the springboard changes while you approach the springboard, you regulate your steps, and you are able to precisely hit the springboard from trial to trial. So there is information in terms of perception going from the environment to the actor, the gymnast. And there is action or effect in terms of psychology from the actor towards the environment. And this so-called perception-action cycle is also influenced by mental representations the gymnast has about a particular skill. For instance, novices who possess different mental representations than experts are likely to show different perception-action characteristics, because that's why they are experts and novices. A second factor is related to task demands. They define movement goals, and movement goals serve as a reference for a successful collaboration between perception and action. So you have to have an idea about what to do in the environment in order to do what you want to do in the environment. Most important point, that a particular motor behavior emerges as a function of perception-action coupling, and this motor behavior is stable in a specific set of constraints, but it may also change as a function of information and as a function of action. And this is what we want to try to do in gymnastics training or with developing gymnasts. So developing specific relationships between perception and action in complex skills. They are, however, task specific, and I will elaborate on that later in my talk. Last aspect is that this system is very dynamic in nature, so it changes during development and during training. And training influences could, of course, have facilitating effects or even hampering effects. So you see an example here. You approach the vaulting table at a quite high velocity. As I said, the retinal picture changes. You adjust your steps so that you can hit the springboard and perform whatever you're intended to perform. When it comes to gaze control, of course, during run-up you try to fixate your gaze on the vaulting table or the springboard, thereby using a particular visual strategy. There are several theoretical and also empirical evidences concerning gaze control and visual perception, and I want to summarize the most important aspects in the following slides. So one of the first studies comes from Reset and Amplar. The author said gymnasts perform skills on the trampoline such as backward somersaults or straight jumps with full turns. And to address the role of visual perception, the authors did the following. They systematically manipulated the light that reaches the eye of the gymnast. So in some conditions, they had the gymnasts perform with full vision. Under other conditions, they used a stroboscope, always flashing lights on and off during the skill. And in some conditions, there was complete darkness. What the authors could show that there is a task-dependent effect. It's here shown for absolute error during landing. So the most stable landing, of course, occurs under full vision, and the worst landing occurred under complete darkness. But it was task-dependent. That is to say that this worked during a backward somersault, but it almost made no difference during a straight jump with full twist. This is the first argument that I want to make. Expert use task-specific visual feedback in complex skills. So it's not that gaze control visual feedback has in general the same function for each and every skill in gymnastics, but it's rather task-dependent. You can't compare a straight jump with full turn or with full twist with a backward somersault. During different tasks, different perception-action coupling, different gaze control. Lewis and Tremblay conducted a quite similar study. So the author said gymnasts perform backward somersaults from a foam block, and what they did was using the so-called plateau system. This is quite a cool thing, you see it here. So the gymnasts were asked wearing these goggles, these plateau goggles, and this is a liquid crystal goggle system, and you can trigger the opacity of the glasses with any kind of information. And what the authors does was having gymnasts perform backward somersaults, and in one condition, that's the V below condition here, the goggles were always opaque, so you couldn't see through under head velocities below 350 degrees per second. The V above condition comprised that vision was available when the rotation velocity was above 350 degrees per second. There was a full vision condition and also a no vision condition. Again, the landing score was used as a dependent variable. And what you can see is that in the no vision condition, worst landing performance, but most interesting, the best landing performance under the V below condition. And this highlighted that visual feedback occurs when there is retinal stability. Retinal stability can be provoked or manipulated during complex skill performance. This is why it's an interesting idea also for training approaches, trying to manipulate or trying to practice gaze behavior in particular in order to optimize skill performance. It's not always the best solution, trying to keep your eyes open, trying to pick up whatever information is available, but sometimes you have to focus your information to quite specific parts. One study from it's Christoph von Lasberg. He conducted a study with non-athletes, advanced gymnasts and expert gymnasts. And what they did was they used the so-called Tübingen vestibular stimulator that is shown on the left side of the slide. So it is a very huge sphere in which the gymnast is seated, and this sphere periodically rotates about the longitudinal axis. So you're sitting in the sphere and it rotates to the left, to the right, around the longitudinal axis. And then there is a light spot projected on the wall of the sphere, and you have to follow the light spot with your eyes. So light spot is not moving concerning the sphere, but sphere is rotating, and you always have to focus your eyes on the spot of light. Then the so-called gain is calculated. That is what you see on the right-hand side. And gain is a measure of the function of the vestibulo-ocular reflex, and it is defined as the change in eye angle divided by the change in head angle during a turn. So when the gain is 1, then you always had your eyes fixated on the light spot. So perfect gaze control is equal to a gain of 1. If you never managed to focus your gaze on the light spot, then the gain is 0. And the study revealed that experts superiority in vestibulo-ocular coordination when compared to advanced gymnasts, but also non-athletes. This was also true for higher angular velocity, so the right part of the slide, angular velocities above 100 degrees per second. Experts were able to focus their gaze on the light spot even at higher angular velocities. So own research utilizes so-called eye tracking methodology to assess gymnast gaze behavior. You can see it here. This is Martin Kumowski, a German trampoline gymnast, wearing an eye tracking device when standing on the trampoline. And eye tracking methodology, of course, can reveal gaze strategies and complex skills. Not in all skills, under all situations, because on the right-hand side you see Li Long performing a triffis on the trampoline. And given the high dynamics of several skills, such as when performing a triple somersault, gymnasts won't, of course, be able to fixate their gaze because the angular velocity is higher than the functional range of the vestibulo-ocular reflex, even in trained gymnasts or even experts. We come to that later. So gaze behavior assessed by eye tracking methodology, from my point of view, a quite simple approach to integrate in daily training. A recent study by Sato and colleagues, gymnasts and non-gymnasts were asked to perform straight jumps with full turn, and they assessed their gaze behavior, and results revealed that usually most gymnasts use a spotting strategy with a single step gaze. So fixating your gaze in front of you, performing the full turn with the straight jump with full twist. The head immediately rotates around and again tries to fixate the gaze in front. So a single step gaze strategy, trying to fixate, rotate as fast as you can, and trying to fixate your gaze again toward the front. And the final aspect of empirical evidence is related to the role of environmental information. This is the second part of my talk later. So one theoretical concept comes from the work of Li and colleagues on time to contact information. And as we thought about earlier, imagine a gymnast approaching the vaulting table at high velocity. So you may argue that the retinal image of the springboard on the vaulting table changes as a function of the state of motion of the gymnast, and this determines the time to contact to hit the springboard. The question would be, however, which are the significant cues in the environment that define this time to contact information in order to precisely hit the springboard, but also to precisely hit the vaulting table, also to precisely stick the landing. I will come back to that aspect later in my talk. So taken together, there is strong empirical evidence that visual perception is of very high importance in the control of complex skills. And as I said, I will focus on two particular aspects in the following. The red point on the left side, so gaze control when performing these skills, and also the role of environmental information therein. So let us now come to the aspect of visual strategies. When measuring visual strategies, or when measuring gaze behavior, more generally speaking, usually eye tracking methodology is used. You see an example here. It's a gymnast performing on the trampoline. He's doing a backward somersault, then he's doing a double back somersault with 2 twists. You can see his motor behavior on the bottom. You can see his gaze behavior in terms of his eye movements on the top left corner. He also had a miniature camera attached to his eye tracking device, taking pictures of his field of view, but it's the upper right corner, but this is a bit confusing. However, just take a look at his eye movements for a second and yeah, just observe. Then you can interpolate or get an idea on where he is looking during the double somersault and double twist. It's interesting to note that the gymnast said that the skill is easier for him to control, for instance, than a double layout somersault, because if you observe the pattern of his eye movements, then you can see that he is able to direct his gaze towards the trampoline bed almost throughout the whole skill. So gaze behavior enables the gymnasts to anchor his gaze towards the trampoline bed, and interestingly, you cannot do this voluntarily. So if you try to use such an eye movement, then you do saccade around the area, but you're not able to perform such a smooth movement of your eyes. Research using eye tracking methodology highlights two aspects. So first, we find differences between experts and novices. Experts show an optimization of gaze behavior, and they usually show no blink, so his eyes stay open the whole time, even at high angular velocities of the head. And second, there are clear relationships between kinematic parameters and gaze behavior, such as the landing position in a skill or specific changes of hip angle and shoulder angle during skills that are related to gaze behavior. We will have some examples on the aspects just mentioned on the following slides. So here you see the results from a recent study. We had novice and expert trampoline gymnasts perform back tuck somersaults under different conditions. And we analyzed the so-called fixation ratio, which you can see on the y-axis, which is an indicator of total fixation duration, subtracted by duration of the movement phase. So the higher the fixation ratio, the more visual input the gymnasts had during the somersault. And the results were as follows. You can see that novices have a fixation ratio of about 40% during the takeoff phase, about 35% during the flight phase, about 50% during landing phase. If you compare it with experts, then experts outperform novices during takeoff, so 50% of fixation ratio, and almost 70% during the landing phase. This difference was also significant, and it can be concluded that experts exhibited differences in visual strategies as compared to novices, which are of course likely a result of their expertise. And these differences may also account for particular movement optimization when performing these backward somersaults. Quite surprisingly, here you see a picture of the eyeball during the movement from an expert. So eyes are quite open as compared to novices. Most novices have their eyes closed. That is to say that they show blinks during high angular velocities of the head. And if you close your eyes, you're of course not able to immediately fixate your gaze towards the landing area. So you cannot prepare the landing or the next takeoff, next skill. And this occurred in about 20% of all cases. Visual strategies may also reflect blackout or lost skill phenomena in gymnastics. Here you see a gymnast performing backwards somersaults on the trampoline, and this gymnast suffered from lost skill syndrome that emerged during a double somersault with a double twist. And he's an expert, however. He lost spatial orientation and crashed during skill performance. And after this accident, he was not able to perform the skill again. One could now speculate, in particular if you look at his gaze behavior, that this incident may have resulted in some significant perceptual changes. However, we can only speculate about that, but we are not able to measure that because you cannot experimentally induce lost skill syndrome in gymnastics. no ethical committee would accept that. However, you always find that perception changes when lost skill occurred. So I will speculate about it later in the second part of this workshop when it's about lost skill. But this is what you find most of the time. So perceptual changes due to or after lost skill. As I said before, that there's a close interconnection between gaze behavior and motor behavior. And this time we asked expert gymnasts to perform dismounts from the high bar and analyze their gaze behavior. You can see it here for a double tucked somersault. Gaze behavior of the gymnast together with his motor behavior. Again, there are no blinks, so I stay open the whole time. There's only a short blink just at the moment that he landed the dismount. And what became obvious was that there were some very strong relationships between different locations where gymnasts fixated their gaze and particular kinematic parameters. For example, fixations to the ground, as can be seen here, corresponded with gymnasts' flexion and extension and flexion movement during the giant swing. So this approximated the direction, or better to say the moment in time when gymnast started to extend his hips. And, this direction was closely connected to the moment when gymnast tried to flex his hips. It was also apparent that there was a close relationship between gaze direction and landing position. So these correlations in terms of statistics were all statistically significant. However, we can only speculate about a causal relationship because correlations have no causality per se, but give a good indication on how the process works. So it can be concluded that directing gaze to particular locations may be functional in the execution of this skill. And this relationship may also serve as a predictor of motor behavior and could also be used in daily training. However, there's no causality, but I'll come to that now. You'll see an overview of an experiment we conducted addressing the causal nature of gaze behavior and motor behavior. We had gymnasts perform dismounts from the uneven bars, so these tucked somersaults. And what we did was we projected a light spot to their normal landing position, as you can see here. What the gymnast didn't know was that the light spot was manipulated plus minus 20 centimeters compared to their normal landing positions. And we asked them to fixate their gaze on the light spot during the downswing phase, but the light spot was switched off as soon as gymnasts left the bars in order to prevent feedback effects. Once the hypothesis was if there is a functional relationship between directing gaze there, manipulating this position, and this should immediately lead to a different landing position, but also a different coordination of the downswing in terms of extension and flexion of your hips. What happened was the following. Here you see quite a prototypical example of the gymnast performing this tucked somersault. So gaze behavior was directly related to motor behavior, and gymnasts adapted the downswing movement in order to land on the spot. The effect of landing distance, however, was on average smaller than the manipulation itself. But it gave a good hint that there is a close relationship between gaze direction, of course, and landing position. So when directing or when placing the spot closer to the bar, then the landing distance was reduced. Putting the spot farther away from the bar, then the landing distance